You have seen in a circuit, a cell or a battery is always attached to supply current through the conductor in that circuit. Now, the current which is produced in that circuit is very small. You must be thinking, why I am telling all these things today? Well, today we are going to study how we can produce electricity on very large scale. So here we go. Electromagnetic induction. This is a phenomenon through which electricity can be produced on a large scale. Yes, and that was found by a great physicist, Micheal Faraday, 200 years ago. But still, now we are using this phenomenon to produce energy and to transport the energy here and there. We have studied in previous class, whenever electric current flows through a conductor, magnetic field is produced through it, isn't it? Now just imagine, is it possible if you reverse the scenario? That means, can a magnetic field leads to generation of current? Let's see. It was first studied by Micheal Faraday. He studied that when a conductor without any connection of any kind of source of electricity is placed in magnetic field because of the magnet, that conductor was able to produce or conduct electricity through it. Well, it was for very small fraction of time, but isn't it wonderful? Let's study further the curiosity of Micheal Faraday. This time, he exchanged the magnet with electromagnet like this, which has a key and a battery or a cell to supply the electricity in this electromagnet, which is in the form of solenoid. Now student, when the key is closed, circuit gets completed, current starts to flow in this, and hence what will be generated along this solenoid? Yes, absolutely right, magnetic field. So now this is electromagnet. Am I right? Because the magnetic field is generated by a conductor through which current is flowing, and hence it is called as electromagnet. Now students, see this. If you bring any conductor which is not connected with any source of current, what's going to happen? Now with this conductor, Faraday attached a galvanometer. What is galvanometer? It is very sensitive device which can detect even the smallest amount of current flowing to any conductor with which it is attached. Alright, so it just detects the amount of current, if current is flowing through the conductor or not, and it can detect the smallest amount of current in it. Okay, are you all ready now to see what has resulted out of his curiosity? Now, when the key was closed, wow, can you see the needle in the galvanometer deflected? And that happens when the current flows through it. So galvanometer needle deflected, and it will only deflect if there is some presence of current in it. But after some time, the needle went back to zero. So again, he opened the key, and again he saw little deflection in the galvanometer. He continued it for some time. What he continued? That is closing and opening of the key. And hence, while doing so, current in the solenoid was getting either increased, decreased, or becoming zero, right? If you open the circuit, if you open the key, the circuit gets incomplete and slowly the current will decrease, right? And if you open the close the key, then the circuit get completes and the current starts to flow. But the current will flow, and it won't happen just like if 1 ampere has to flow, so the amount of current will increase. Okay, it won't happen like throughout the solenoid 1 ampere of current is transported or going, right? So it increases little by little. So opening and closing the key, what he was doing actually, he was increasing or decreasing the flow of current in the solenoid. You can say changing the electric current, right? And changing the electric current through the solenoid generates magnetic field around it, that you already know. So that means when you tend to change electric current around the solenoid, magnetic field also changes. And hence, this leads in the production of electric current in the nearby conductor, which was attached with the galvanometer. Faraday confirmed this with changing position of the conductor too. That means he kept the solenoid in one place with the key closed. That means the current is flowing in the solenoid and hence the magnetic field is produced. And now what he is doing, he is bringing the conductor nearby or taking it away from the conductor. That means forward and backward direction he started to move the conductor. Then also there was a deflection observed, okay, in the galvanometer. Now this leads to conclusion that when solenoid with current was moving but conductor was kept stationary, it generated electric current in the conductor. Changing the solenoid, meaning either you can open and close the key or you can move the solenoid with the closed circuit. That means the circuit is closed and you keep the conductor in one place, and the current carrying solenoid, that if it is changing the place, then also the current was seen to be produced in the nearby conductor. Okay, so there are three scenarios: opening and closing of the key, keeping the conductor and the solenoid stationary. Second, keeping the solenoid stationary with the key closed, making the conductor move here and there. Now, in third scenario, keeping the conductor stationary and then a closed circuit solenoid was moved, okay, here and there. So in all the three scenarios, there was a deflection in the galvanometer. Okay, so what was happening? By now, it was clear that when the key was closed or open, it was leading to flow of current, either increasing or decreasing, and hence, due to increasing and decreasing, magnetic field was also changing, and that was leading to the electric current to be produced in the nearby conductor. Same thing happens when the conductor was brought in the magnetic field produced by the conductor. That means conductor was moving to and fro. So in that case also deflection was there. But there wasn't any deflection if there was no change in the magnetic field. That is, the conductor was stationary and the same amount of current was flowing in the solenoid. So there wasn't any change in magnetic field. How you are going to change the magnetic field? If you change the place of the conductor. So conductor, if it comes near, it will be in vicinity of more of magnetic field lines. If it is going far, so there is lesser and lesser magnetic field experienced by this conductor. That is why the changing magnetic field was leading to production of the electric current in this conductor. So such production of current due to changing magnetic field by other conductor is known as induced current. So if somebody asked what is induced current, don't tell the current which was produced from the battery. No. Okay. Here it is produced because of the changing magnetic field, and hence we call it electromagnetic induction. As the magnetic field was produced by the current carrying conductor, hence it is electromagnet, and hence we call it electromagnetic induction. Now, why it was so important to study Michael Faraday electromagnetic induction? What is the use? Well, because of it, student, whenever you see presence of electricity, that is only because of this phenomenon, that is electromagnetic induction.